So I'm Bill Norris. This is Rich Fanis. We're here to talk about some of the things that we've seen coming up. And Eric's talk was great right there, because that's a lot of stuff that we've recognized, and we're trying to see how can we take this a step further, and maybe even another step further. So some of the stuff that we get toward the end is rather speculative, but I think it's a good precursor. Rich and I have worked together for over 2 decades. I recently started my own company, Ecosystem Restoration Services, this year, and it didn't take me long to figure out. I was talking to a friend who was fishing in Alaska this summer, and I asked him how the fishing was. He's like, there's this big algal bloom, there's no fish around. I've been fishing here 20 years and I've never seen this. And that's when it was just kind of like a bonk on the head for me. It's like Ecosystem Restoration Services implies that you're kind of looking backward to some reference. And where our ecosystems really need now is resiliency and adaptation. It made me realize right then I had a problem with the name. So you're getting a first look at what our name's going to become at the first of next year, Headwaters. And it just so happens that ERS is at the end. Just a little outline. I'm going to go over equipment overview, and mainly I'm talking about surveying equipment. I'm coming at this from a design standpoint, but I can't help but see so many opportunities for monitoring with some of this discussion. And I hope it's not too much review, but I wanted to make sure I wasn't taking anything for granted as far as what people knew about surveying and whatnot. So total station. I don't think we're ever going to get away from a total station survey instrument, because we can get under canopy and out of GPS signal and still get good points. We can get pool depths. We can survey cross sections underwater that LiDAR is not going to see unless you use green LiDAR, which has to have clear water, and we don't always get that. And it often takes a long time to get points to so many setups. On the other hand, if they're using this next instrument, RTK, it's a survey grade GPS, that gets great data fast out in the open, but when you get down in the canyon, the GPS signal isn't very good, and you have to rely on a total station. So what the RTK can do is get you your own points. You get a setup point and a back site, and now you can really start shooting with a total station. I think all of you are familiar with that, but I didn't want to take anything for granted. And just so happens we did demo this Tremble unit recently, and it shot a lot better than anything we've ever used in the canyon. And those two in combination are really how we've been doing our work for over 20 years, shooting in these forested canopies where there's bad GPS signal. But what we're typically developing for design is you're looking at a bunch of cross sections there. We build in a 1D model, hydraulic model, and that's pretty much been our bread and butter for decades. And it's been great, but what we're seeing is that there's new ways to do things, obviously with the UAVs or drones or whatever acronym we want to give them. So when we first started doing this, it was like, wow, let's go up and just document project conditions. This is really neat stuff. It was just kind of, we can show people what we've done out here. And then we started to think about structure for motion and how we could develop 3D point clouds, which is, I'll talk about a little more for design, but for me as a designer, I want to know where are there existing trees that I can lock a large piece of large wood into. I want all the information. I just want cross sections. I don't want just longitudinal profiles. I don't want tops and toes of banks that are tied together in break lines. I want it all. And with structure for motion, I think you saw a little example of that from Eric's. It's kind of like what you see is what you get. And before I go into our structure for motion experiment, which we did last year, just one last thing about LiDAR, which I'm sure you're all familiar with. We usually end up having to resurvey the stream after the LiDAR is flown, because LiDAR is usually several years old. The stream has moved since then, and we need to understand the differences between where the stream is now and where it was when it was flown with LiDAR. What we end up doing a lot of times is getting those brake lines along the tops and toes. We get our tail leg brake line, we get our cross sections, and we build a DEM in the channel, and then we merge that with the LiDAR outside the channel. That's how we've been doing our work for the last 5–10 years. But like I said before, what we really want is this comprehensive data with georeferenced images, with a structure for motion. You're taking a lot of overlapping images, and the drone knows where it is in space, typically, with from satellites, but in a lot of places we get poor GPS signal. So what we have to do is go out and survey targets that these photos can see, and then we can manually register the photos for those targets. And just like Eric said, we can measure a lot of things, sediment accretion volumes, sediment size, wood recruitment, wood transport, channel width, all that fun stuff. This became, for me, working on Abernathy Creek, really right upstream of that site. That was supposed to be a video, but it's not working. What happened there is we built a channel spanning log jam. We watched the substrate go from probably a D50 that was 12 inches down to 2 to 3 inches. I mean, it was quite dramatic, the change that occurred there. And we said, we need to document this, not just with pebble counts or, no, there's the video. But it's a very hard place to fly a drone, because if you have a bunch of alder canopy and you're looking down from above that canopy, what you see is the alder canopy. So Rich came up with this idea last year when on Abernathy 9B Reach, where he said, I think I have a way to fly. I think we can fly this under canopy and do structure for motion. And I was like, really? And this is what we did. You see a photo up there in the top right, and this point cloud is an image from a point cloud on the bottom left. Those are the same areas. You can see the gravel bars on the left, and some of the gravel on the right are in both. And what we did is we went up and made targets. Basically, these were spray paint on rocks with little numbers drawn next to them. And with all these overlapping and offset images, we're able to register all those. Now, Rich took a lot of low photos, obviously, but anywhere we saw a hole in the canopy, we went up higher to get, get better registration of those lower photos. And sometimes when we got up higher, we got a little bit of a GPS signal, but for the most part, we didn't have it. So it was really important to manually register those photos. How many?
This site, this is just a portion of the site. I believe we had 700 images for the upper half mile, and then we had another additional 800 in the lower half mile.
So this is our first go at that. It might have been a little bit overkill. I know we do it different now. A lot of what you see in these targets are zigzag pattern. We're understanding now we would have got better accuracy if we got 2 points in each cross section at least, just to kind of bring it down to a plane, because we were getting a little bit of twisting, I think, which was adding to error.
And it's such a narrow channel alignment, so you don't have very much width to round out the boundaries of your model.
No, that channel width is 25 to 30 feet. It's a pretty small channel. But as I started alluding to before, I want to know where those trees are, because a lot of times we're locking key pieces into existing trees. The other thing it gives us from a design standpoint is we can go away from those 1D models and run a 2D model now, which in some cases we can run just as fast if we have good data. This type of point cloud data coupled with LiDAR, we could get there pretty quickly. And I'm calling that comprehensive data. From a monitoring standpoint, it became pretty clear, especially some of this is the project I showed you some pictures of yesterday. Before it's on the right, after's on the left. What you don't see in that photo is, on that photo on the right, you see that kind of hump of the bank there. There's probably 20 logs stuffed in there that you can't see from the ground right here. But I know what some folks are doing to go out and document this is to draw sketches from the ground, which are basically creating an aerial view with a paper and pencil and estimating what those logs look like when they're standing on the ground, what they would look like from the air, and it's just kind of a no-brainer that, gee, if we flew this with a UAV, not only could you count them, but if you flew it with UAV and got a point cloud, you could measure everything, and if you did a time series of that, you could see how wood shifts over time. We're going to fly this particular reach once we get enough flows where some of that wood right there moves around, because we didn't want to fly it right away. We wanted to see some of this is just scattered in the floodplain through our access area, and we wanted to rack up before we flew it. So we are going to fly that in the next few months. So to me, this is where I think the interesting thing is, and it's part of how we want to do our documentation for our before and after designs, but I think it becomes very relevant to monitoring as well, is where do we go from in the future, what do we use? UAV LiDAR is kind of an obvious one. We can get great bare earth images. We'll know where trees are. They could be filtered out from the bare earth. One thing we can't see, and one thing that's been requested from my client, is he wants to know when side channels begin to water up on the floodplain. And in Abernathy Creek, where our goal is to kind of lift the main channel up in elevation through sediment accretion, what we would see if we just did UAV LiDAR is we'd see a high flow channel one year, and we might go back and fly it the next year, and it still looks like a high flow channel with a bare earth. But what has happened is we've lifted up the channel, and now it's a side channel. It's watered up year round. I mean, that type of thing has happened. So I think it's important also to get the photos under canopy. I would also like to have the point clouds, not just of the treetops, but I'd like to know where how those tree trunks are aligned, so when I go into design, I know where I can lock in trees and lock them together, and it becomes this tool that's much more accurate from a design standpoint. From a monitoring standpoint, it's much more accurate. Another thing that's available are these ground scanners. You set it on a tripod on a known spot, spray points everywhere. That's used a lot right now in new buildings. So you have an architect that is looking at their as-built conditions for their building. They send someone in with one of these scanners. They scan the whole thing, and they get a 3D point cloud. A lot of these have cameras as well. And then they'll sit in their office and they'll count the number of pipes or, whatever they count. We've been talking to a lot of folks about acquiring some of this equipment, and they kind of look at us like, you want to do that outside? Yeah. So for one, I think the UAV LiDAR holds a lot of promise, but the next thing that I think holds even more promise for us and the data that we want to get is the ability to take that same LiDAR puck from the UAV and put it on a backpack. Now, both these units are fairly new right now, the backpack units are fairly new right now, but that's where we get into mobile mapping. That's where it's got a GNS satellite knowledge of where it is from the GNSS system of satellites, and with a base station RTK, you can begin to walk around, spraying points with LiDAR, and couple that with a camera, and now you can get the 3D point cloud with a photo behind it. For us, that's, I think, the next step of where this is going to go. That unit right there is, from what we've been pricing, about $75,000. The aerial drone is $50,000 to $60,000, but the cost of both those things is the LiDAR puck. So if you can get the LiDAR puck to come off the backpack and get put on the UAV, now you've got something that you can get comprehensive data with above and below the canopy, bare earth, vegetation, watered up with photos. You can tell if it's watered up or not, or what the difference is. Obviously, this is all very speculative now, but these are tech talks, and I think it's really important to look forward and how are we going to be doing this work in just a few years. And I think this is I think this is going to change the way that we do work as designers, and I think it might be possibly change the way we monitor projects. So that is my tech talk for now. Thank you.